So today what we are going to deal with in our chemistry we are going to continue what we have stopped, that is acids and bases. Yes, in acids and bases what we are going to do today, can you please recall what we have done in our last class? Where did we stop? Yes, today we are going to learn definitions first. As the class moves on, I will go through what all we are going to learn today. We are going to complete acids and bases in this session. Okay? So, in definition, we came across three theories. For acids and bases, we have came across three theories. The first one is Arrhenius theory, and the second one is Bronsted-Lowry theory, and the third one is Levis theory of acids and bases. So we will go one by one. Okay? First we will see what is Arrhenius theory, what it says about acids and bases. Let's get started. Arrhenius in Arrhenius theory, Arrhenius is an old scientist. What he said, acids are an elements or solutions which in water liberates H plus ions. Acids are the substances or the elements which liberates H plus ions in water, and at the same time bases. Bases are elements which liberates OH minus ions in water. So according to Arrhenius, acid is a substance which liberate H plus ions in water, and bases are the substances which liberates OH minus ions in water. When coming to, why the next theory? Why not this is only theory which has been used? We have seen so many acids which don't dissolve in water only. So Bronsted-Lowry theory. Why Bronsted-Lowry theory? Why not only Arrhenius? Bronsted-Lowry theory is because all the acids and bases don't dissolve in water. So what will you do? How will you decide if it is not liberating H plus ion and OH minus ion in water? Then how will you decide acids and bases? For that, Bronsted and Lowry theory. What it says? Acids are the substances which donates proton, It's not a big difference to Arrhenius. You should not get a confusion. Bases are here the the substances which donates OH minus ion. Here also the concept is same, but in Arrhenius he said only in water. But in Bronsted-Lowry theory, water insoluble acids and bases. Example, if I say acetic acid, CH3COOH, it is sparingly soluble in water. That means it don't completely dissolve into water, but it liberates hydrogen ion. You can see proton H plus, it liberates. So according to Bronsted-Lowry, this is an acid. The same way, if we say for bases, you can see calcium hydroxide, magnesium hydroxide. These don't dissolve in water, but they do liberate OH ions. So these are bases according to Bronsted-Lowry theory. Then we have not, the history has not stopped to Bronsted-Lowry theory for acids and bases. It again came a step forward by Levis. Why is that so? Why Bronsted and Lowry is not the final theory? Only H plus and OH minus ions have been discussed. There are so many acids and bases which don't contain these two ions. So that will be explained by Levis theory. The Levis theory tells us about electrons. Here we consider electrons. So here Levis theory says acids are the substances which accepts electrons. Which accepts electrons. Example, AlCl3, FeBr3. See here, there is no hydrogen ion, there is no hydrogen ion, but these two are acids. So they can accept electron from some substance, accepts a pair of electron, not a single electron, pair of electron. These substances are acids according to Levis, so they are called as Levis acids. They accept a pair of electron. Now you can easily say what are bases according to Levis. According to Levis, bases are the substances which donates a pair of electrons. The very famous, familiar and important base of Levis is NH3. See here, it is not having any OH ion, it is only having hydrogen, but still it donates a pair of electron. So it is a Levis base. Okay, so now it is completely clear. Why? There are three theories for acids and bases. pH. How pH is important? What are the variations in pH? How we can decide what is acid and what is base according to the pH scale? Actually, we call this as universal indicator. Universal indicator. In universal indicator, all the indicators which I previously told in the previous video, the methyl orange, phenolphthalein and all are mixed together, and they will let us know there are two types of universal indicator. One is a paper, we call that as pH paper, and another one is pH solution. These two are universal indicators. They will tell exactly the given solution is acid or it is base or it is neutral or it is nearly to the acidic one or it is nearly to the basic one. So in detail, if we want to know, then pH scale is having a scale range from 0 to 14. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. Lower the pH value. These are, we call it as pH value. Lower the pH value. The value, if the pH value is lesser than the 7, then it is acidic. The given substance is acidic. If the pH value goes greater than 7 up to 14, then the substance will be basic. If the given substance is exactly 7 in between the range, then that is neutral. Have you any idea which substance is neutral, which is not acidic and it is not basic? Yes, that is our water. Water, if you are using a pure water, then that pH will be 7 only. The water is neutral. It is neither acidic nor basic. pH acts on our daily life. If we see pH of soil, pH of soil. Why is that important, that pH of soil? Yes, pH of soil is important to grow the plants and the food we eat, everything related to soil. To have a proper fertilized soil, the soil pH should be 7. That is neutral, as I said. If we use some harsh, or what we say, the chemicals for bacteria and all on the plants, they will definitely go to soil. And the fertilizer, by mistake if we take a wrong fertilizer, or the soil is already basic or acidic and we use a fertilizer to get it neutralized, in that way, if the soil loses its pH of 7, if it gets 6, then it will be acidic soil and is not good for plants. If it gets 8, then it will be basic soil and again it is not good for plants. That way the soil pH is maintained. And where we can use the pH in our daily life, where we can see the pH in our digestive system. In human digestive system, the pH will be of 1 to 2. Where that will lie? Acidic. Yes, you might get confused or you might get shocked. 1 to 2. Yeah, exactly. We will say like HCl will be released in the walls of our digestive system. What it will do, when we eat something, the acid present in our stomach that will digest whatever we eat, and our digestive system work upon the acidic medium of pH. If we eat lot of things, we feel acidity whenever we have not taken food or we have taken excess of food. That time our digestive system will get confused and it will release a lot of acid, and that will cause us acidity. So this is one more pH, importance of pH. And another one is in tooth decay. That is also relates to our body. Tooth decay. Our saliva, which is present in our mouth, the liquid which is present in our mouth, that is also slightly acidic. Slightly acidic means the pH of saliva is 6. Slightly acidic. When you have food and all, the calcium sulfate, our teeth is made of calcium sulfate. Calcium sulfate, this is insoluble in water, and when we have something, the pH will vary and it will get deposited by so many food items we have. So that will cause tooth decay in our mouth, that can be dissolved, that can be cured by toothpaste and all. Okay. So this is pH and its importance in our daily life.
Now coming to properties, preparation and uses. As you might have seen in the last video, you'll come to know what all the particular acids and bases we are going to learn in detail. So this one is the first one, sodium hydroxide. So I am using a whiteboard here. It is very good app where I can help doing my lecturing. So here now I am going to deal with sodium hydroxide. So what are how it will look, the properties of sodium hydroxide. You can see it is whitish solid, available in flakes, granules and pellets. You can see here the flakes, granules and pellets. It will be available this way. It is highly soluble in water, sparingly soluble in alcohol. That means it is soluble in polar solvent. Okay, hence it is strong alkaline in nature. Alkaline is a strong base which is soluble in water, that is called as alkaline. It is strong alkaline in nature and it is also called as caustic soda. Okay, so next, coming to its preparation. See, it is prepared by Castor-Kellner's method in a Castor-Kellner's cell. This is a typical diagram you can see in your textbook. Sorry for the interruption. So this is a brain solution, the combination of NaCl and H2O. We will see the reaction in our next slide. See here. So NaCl and water are treated with electrical energy. The chlorine and hydrogen gases are removed and NaOH, the caustic soda which we want, is available. So this is the preparation of sodium hydroxide. So what are the uses of sodium hydroxide? See here. It is used for making soaps and detergents. And it is used for making artificial textile fibers. Textile fibers means the threads present in the clothes you wear, the artificial one, which we call as synthetic cloth. And it is used in the manufacture of paper. It is used to purify bauxite ore, and it is very importantly used in oil refining and making of dyes and bleaches. So are the uses of sodium hydroxide. Let me revise it. Properties and the preparation and uses. The next element we are going to study about is bleaching powder. You can see in your home and all you use bleaching powder for the floor in hospitals. That bleaching powder, how it will be, you know the properties. It is chemically known as calcium hypochlorite. It is pale yellow powder and it is having a strong smell of chlorine. It is soluble in water but due to impurities, it is definitely having some impurities, so it is difficult to observe clear solution. So the water will be looking like water kind of a milk kind of a thing because of presence of impurities. These are the properties of bleaching powder. Next, coming to next slide, the preparation, how it is prepared. It is prepared by using slaked lime. This is our slaked lime. Slaked lime is nothing but chuna. In Hindi, it is chuna. When it is treated with chlorine gas, the chlorine gas reacts with the slaked lime, dry slaked lime. It will give us bleaching powder with the liberation of water. So this is a very simple preparation of bleaching powder. Here you should remember this reaction. Next, coming to the next slide, the uses of bleaching powder. You already know the uses of bleaching powder. To be in detail, see here. It is used as bleaching cotton and linen in textile industry. To be stiff and to have a good texture of clothing, we use bleaching powder. And it is used in wood pulp in paper industry. Sorry for the interruption. Baking soda, it is white crystalline, sparingly soluble in water. You can see it is available in your home, you can check it. It is used to prepare washing soda also, and it is non-corrosive base. Non-corrosive means if you say any iron metal, iron element, if you deal that iron element with water, it will corrode. That means it will get rust. But when it is left with soda, baking soda, that won't get corrosion. So that is non-corrosive base. Then coming to its preparation, the baking soda is prepared by solvase process. This diagram and this detail is not in your syllabus, so it is not that important. Only important is the raw materials and the chemical equation involved in this process. So the baking soda solvase process is same as for that of washing soda also. Washing soda will be prepared by the same method using baking soda. So this is the equation, chemical equation. What exactly the raw materials used here are, the first one is sodium chloride. We have seen this sodium chloride brine solution during the preparation of sodium hydroxide previously. Same here, NaCl, and along with that brine solution we are having concentrated ammonia and carbon dioxide. So these three are important, and it is solution, so no doubt it will have water. It will be very easy for you to remember. Sodium chloride, ammonia and carbon dioxide. At last you can write water. You can interchange this while writing, but it is good if you write in the same way. What it will give? It will give us sodium hydrogen carbonate. This is our baking soda, along with the formation of ammonium chloride. Ammonium chloride. This is a byproduct. Byproduct means which is formed during formation of any other product. This is our main product and this is our byproduct. So this is the preparation of baking soda, NaHCO3. Now coming to the uses. What are the uses of baking soda? You know it very well. Especially very important one is it is used as an antacid in medicine to remove acidity of stomach. As I said in previous video, that in Eno and all the soda will be there. It is used in making baking powder. Baking powder is one more thing, like it is used for preparation of cakes and all. How it is used means, when baking soda mixed with water, then sodium hydrogen carbonate reacts with tartaric acid to evolve carbon dioxide, that is formed as baking powder. Then it is used in fire extinguishers. That means it will help in reduce the fire, burning fire. So these are the properties, preparation and uses of baking soda. Next, we have seen baking soda. Now it is our washing soda. How it will look like, what it is exactly. Washing soda is nothing but a detergent, washing detergent. It is crystalline, transparent, white solid. You can see ditto, just like our soda, but it is completely soluble in water, and it is also basic in nature. It has cleansing properties. Cleansing means cleaning properties. We can't use this for eating. It can't be edible. It is used for cleaning. Then how it is prepared, as I already said, it is also prepared by Solvay's process. The diagram and the detail is not required for you, only is its chemical equation, how it is prepared and all. It is actually prepared from soda, baking soda only. As I previously said, the raw materials for this are also same: ammonia, carbon dioxide and water, and brine solution, NaCl. Then the reaction happened is, you already know, the baking soda is formed with the formation of ammonium chloride. This baking soda is taken and it is heated. This symbol you see, the triangle, it means heat. When it is heated, water and carbon dioxide are released and we will get our washing soda, that is sodium carbonate. This is the preparation of washing soda. If in exam it is asked for preparation of washing soda, you have to write all these three reactions. Let me clear this so that you can get the perfect reaction. You can take its screenshot. See these three reactions. For baking soda, you'll be having these two reactions. For washing soda, you have to write all the three reactions. You can't directly write the last one. You have to compulsorily write all the three. 1, 2, 3. This is NH4Cl. The printing is not proper here. That is ammonium chloride. So next, coming to its uses. What are the uses of washing soda? As I already said, it is a cleansing property. It is having cleansing property. So it is definitely used for washing cloths and used in manufacture of glass, soap, paper. Coming from top, it is very importantly used to remove permanent hardness of water. If you say you are getting borewell water, hard water, we will discuss that soft water, hard water in other topic. So it can be removed. The hardness of water can be removed using washing soda. And it is used in preparation of glass, soap and paper. It is used in washing clothes. It is used in the manufacture of borax. So these are the properties, preparation and uses of washing soda. The last content of this topic, that is our plaster of Paris. You can see this is not ice cream, this is plaster of Paris. Plaster of Paris, how it is, what are the properties of plaster of Paris? It is white fine powder. It is also called as calcium sulfate hemihydrate. Hemihydrate means it don't contain a complete water molecule. It is having half of the water molecule. How we will discuss in this session just in while. It gets harder if exposed to moisture and allowed to dry. Just as cement. Have you seen cement? When it is allowed to dry, when after mixing, it will get hard. The same way, the plaster of Paris also gets harder. Next, coming to the preparation. How it is prepared. Here also, the equation is important. In every preparation, In every preparation, you should go through the equations, write them down 2-3 times. You will easily remember. You will never forget them. Okay. So what happens? We are going to use gypsum for the preparation of plaster of Paris. Gypsum is heated. Just gypsum is heated. No any other content. Nothing. You'll be going to easily remember this. But the heat should be very important. The heat should be of 373 Kelvin. That should not be lower than that. That should not be higher than that. So gypsum is nothing but calcium sulfate with 2 molecules of water. But our plaster of Paris, which we need, the plaster of Paris, if you see the equation, coming to equation, this is also calcium sulfate but half molecule of water. As I said, it is hemihydrate, half molecule of water. These are the preparations of plaster of Paris. And next, coming to uses, it is having variety of very important and good uses in every field, I should say. Our homes, our offices and our art and everything has become so good with the use of plaster of Paris. And first of all, even in our medical uses also, it is used in hospitals for setting fractured bones in the right position to ensure correct healing. You may have seen, if you have fallen, you may have seen so many faced accidents. They'll be covered with white packaging kind of a thing, bandage, the heavier one, that is nothing but plaster of Paris. Then it is used in making toys, decorative materials, cheap ornaments. Yes, ornaments, they are made up of plaster of Paris and they will be painted silver and gold so that they look like original metal. And it is used in chemistry laboratories for sealing air gaps in apparatus for airtight arrangements. If we want to observe reaction in absence of air, there POP is used. We call it as POP also. And it is used for making surface smooth before painting. You can see we call it in general language that lappa, putti, white putti, wall care putti and all. That is nothing but plaster of Paris. That is used in making surface smooth before giving a last finish paint for the constructions. So these are the properties of plaster of Paris, preparations and use.